We're going to write a linear inequality from context. To do that, we might need to highlight any numbers, and sometimes the numbers will be in words or invisible one that we see, with the keyword that goes with it. I usually keep the order of X if it's first and then Y. And then you're asking yourself, what is the key vocab that represents the inequality? And if you need to know the vocab, you can look at page 30. And then you write down the sentence representation. So I'm going to start off with example 2. And as I'm reading this, I'm going to highlight any key words that I recognize based on what we've learned on page 30. All right, so it says Catherine is working 2 jobs. Okay, so she's working 2 things. So there are only 2 possibilities, lifeguarding and walking dogs. She wants to work more than, okay, so that's a key word from page 30. So more than 14 hours altogether is a keyword. Write an inequality that will represent the possible values for the number of hours lifeguarded. And now, so it's telling us what we're doing. So the number of hours lifeguarding L and the number of hours walking dogs D that Catherine can work given in a given week. So if you notice, we have a graph here, and I've gone ahead and written it for you. Said the hours of lifeguarding L and the hours of dog walking D. Okay, so I'm writing an inequality with L and D, and then I just need to put in more than. So going back to page 30, pause the video and go look at what more than looks like. All right, so let me ask you this question. Can I have 13? If I want more than 14, can I have 13? No. Can I have 15? Yes, because 15 is more than 14. Okay, can I have 14? More than 14? No, because more than has to be more than. So I can't have 14, but I can have 15, 16, 17, 18, 19, 20, 21, 22, 23. As you can see, I'm going to the right-hand side. And if you look on the x-axis, the right-hand side is greater than. My right hand is greater. So I should have this more than has that. Okay, so between both jobs, number of hours lifeguarding plus the number of hours dog walking, total must be greater than 14. And that's how you write an inequality. So just based on the information they give you. Now that I know that, I can put that in the calculator. And as soon as I put L plus D is greater than 14, I can already see an error has appeared. And that's because we only plot inequalities of X and Y. Okay, so my first one is going to be X, my second one is going to be Y. So you just have to remember which is which. So X is going to be lifeguarding and D is going to be Y. So as soon as I do that, you can see it's graphed something. So I'm just going to press home so I can see it. So there's my graph. Now I need to transfer my graph from here to my paper. So let me start off with my y-intercept because that's an easy one. 0, 14. So here's 14. 0, 14. You're going to put a dot. And then I'm going to go to my x-axis. And that's going to be 14, 0. Just pay attention to the fact that it is a dotted line. So make sure that your line is dotted. Okay, and then we're going to shade which side of the graph. So I'm going to zoom out so you can see it. So we're shading this top part or the right-hand side of the graph. So again, you can take a color pencil and just lightly shade this side, or you can just represent it with lines like so. All right, so now that I have this, I have some questions that I need to answer. So for one, let's select all the solutions that apply. So automatically, I know, again, what is my x, and I'm going to label my x and my y just so that you can see what it meant. So this is my x, this is my y. All right, so my first number is lifeguarding. My second number is dog walking. So it's the number of hours walking the dog, number of hours lifeguarding. Can I have -1 hours walking lifeguarding? No. So automatically I know that this does not apply just by the fact that it's a negative. Okay, so everything else I do have to check, type it into the calculator. So I'm going to copy all of this into here on separate lines. Okay, so you can see that it's scattered dots everywhere. So to kind of look at them one at a time, we're just going to click on the color so they're going to disappear. So this one, and we're going to zoom in. So this is going to be very important. Please zoom in to make sure. Sometimes it looks very close, but it's not quite on it. I can see that this point is on it. So right now, remember from previous videos, can my solution be on a dotted line? No. So this is also not a solution. Now we're going to look at the next one. So we're going to hide that one and go to 4 and 9.5. I don't even see the red dot. So I'm going to zoom out. Oh, there's the red dot. And that's clearly not in the shaded area. All right, then we're going to go to 6, 9. So let's put that in. Okay, I don't have to zoom in to see that one. That one's definitely in the shaded area. So this one is a solution. Next one. I don't see that one. So let's zoom out, zoom out, zoom out. Oh, there it is right there. So random, but it's totally not in the purple area. So this one is not a solution. And last one. All right, zoom out, zoom out. Okay, that one looks like it could be on the line, but we're going to zoom in just to make sure. Yep, that looks like it's definitely on the line. So on the line again, it's a dotted line. Is that a solution? No. So the only one that could be a solution is D. All right, what does a solution 11,7 mean in context? So if I type in 11, 7, this should be in the solution. And I don't like that it's the same color as my solution. So I'm going to long click the color and then I can change the color. All right, so zoom out so I can see there it is, definitely in my solution. What does it mean? So remember, this is my X and this is my Y, but in my problem, X is hours lifeguarding and Y is hours walking dogs. So what does 11,7 mean? Who's this person? Catherine. So remember, you always start off with the name. So Catherine, and what is she doing? She's working. Catherine worked. Okay, so Catherine worked 11 hours as a lifeguard and 7 hours walking dogs. And really, I can say she wants to work more, right? And equality represent. These are the possible. So Catherine possibly worked 11 hours. So let me add that. Possibly, because I'm just reading what the context is. So Catherine possibly worked 11 hours as a lifeguard and 7 hours working dogs. Okay. If you know, Catherine worked exactly 10 hours walking dogs. So which one was walking dogs again? The Y. So my Y is now 10. Okay, so I can come here. My Y is right here. Okay, so if she worked 10 hours walking dogs, what must be true about the number of hours lifeguarding? Okay, so if she worked 10 hours working dogs, she can't work this many hours lifeguarding, but anything greater than that is fine. So in order to represent that, to kind of give you a visual, I want it to be on my Y-axis. So I'm going to write Y equals, and I want it to be the 10. And you can see it's giving me the visual. I'm just going to hide this real quick. So if she's working 10 hours walking dogs, lifeguarding, can she work 4? No, because this is on the dotted line. So she can't work this because it's on the dotted line. But anything greater than that is in my solution set. So she can work at least 4 hours on lifeguarding. So how do we write that? And I said the word greater than, so hopefully you heard it. L is greater than 4, but not equal to, right? Why can't it be equal to? Because it is a dotted line. So anything greater than 4 is going to be fine for her. Now, before I can finalize this answer, let's think about this real quick. If I say L is greater than 4, that means in the real world, I'm including decimals and everything in between. Does that make sense in this context? So if I'm talking about hours, can I have 4.5 hours? Yes. Okay, so I can write it this way. If I couldn't have 4.5 hours, I'd have to say whole numbers where L is greater than 4. Because that will give me 5, 6, 7, 8, 9, 10, 11, 12, 13, etc. All right, so just be careful with checking to see if it makes sense for the real world. Okay, so finally, let's look at domain, and just reminding you, what is domain again? It is X values from left to right. Okay, so looking at the X axis starting on the left, okay, this is real world. So can I have -1 hours lifeguarding? No. So I can have 0 though, right? Yeah. So we're going to start at 0. Can I have 0.5 hours lifeguarding? Yes. Okay, so this one is not discrete. This is continuous. Okay, so this is not discrete. This is continuous. So I'm actually going to write that down. Continuous. Okay, which means it can has decimals, right? And then where do I stop working as a lifeguard? I don't. So even though it's 13 hours, I can work as long as I work 4 hours walking dogs, 15, 16, 17, 18. So this technically is going on forever, including every fraction. So I can do this, and I can do closed on 0 because I can work completely 0 hours, open on infinity because I don't include it. In this case, I mean, does it make sense to work infinity hours? Probably not, because you're going to die at some point. But theoretically, domain is 0 to infinity. All right, range is your y values from the bottom to the top. Okay, so looking at the bottom, can I have, and this is hours dog walking, can I have -1 hours dog walking? No. So just like domain, it starts at 0. All right, can I include the decimals? So I'm going to have 1.5 hours dog walking. Yes, I can work for an hour and a half. So that's going to be, again, we can write it like what we did above. And then can I stop? I can just keep going working forever, because at 7 hours, even though it's not shaded here, as long as I lifeguard for 9, I'm good. So I can work 7 hours. So I can work all of these hours going up to what number? Infinity. All right, so that's example 2. You should be able to do example 1. Let's practice.